So let's start with the today lecture. This we have already studied, the verification of dual nature of matter, and this is the wavelike properties of the particle, and X-ray diffraction and electron microscope. We have compared the results when we discuss the wavelike properties of the particle. So here there is another way to prove the wavelike nature of the particle, and the example is the electron diffraction. Similar to the X-ray diffraction, X-rays are the rays, electromagnetic radiation, and the electrons are the particle. And if they are diffracting in a similar way as the X-rays are diffracting, that means it is having the wave-like properties. So, because why I'm going to discuss over here, because the same phenomena or the output of this lecture we will be applying in the future lectures to understand. Actually, briefly we will discuss what is the electron diffraction and actually what is the outcome coming out of this electron diffraction. So here there are, again, it is a wave. These are the waves as represented over here, but there are two interferences, two types of the interferences. One is the constructive and the other one is the destructive. So what is the constructive interferences? So it must be if the waves are in phase, and they will produce the wave with the increased intensity, like this is the wave traveling, okay, and this is another wave. So what is the difference between these two waves? No difference, because why? Because the crest is matching with the crest and trough is matching with the trough. That means two waves are in phase. When two waves are in phase and meet together, the intensity of the two waves is more. That means it is the sum of the intensity of the individual waves. So this way is called the constructive interference. So they are interfering, they are going to merge together and producing the more intensity. And if it is happening, this is called the constructive interference. So this is very important because we will be using these terms in the future lectures. So what is the other one? What is the difference between these two? Opposite, because here this is the crest and this is the trough. Crest is matching with the trough and the trough is matching with the crest. So what would be the outcome of this one? There is no sum up of these two waves, so they are going to cancel out the behavior of one wave with the other wave. So net result, you will not see the wave. So the net result is the zero. So this is the actually the two wave. One is the constructive interferences and other one is the destructive interference. Clear? That means the constructive interference when the waves are in phase, and for the destructive interference when the waves are out of phase. Phase means in one phase, जैसे हम बात करते हैं liquid or the gases or the solid. Liquid is one phase, solid is another phase, gases is another phase. So all these are present in the same phase or within the phase, and the other one is the out of phase. Let's have a look another example. What do you see? Which waves are in phase and which are out of phase? So first look at the picture A and B. This wave is traveling, this wave is also traveling, सही इसी तरह जो है ये move करेंगे. And if these two waves are in a phase, that means they may overlap, meet together, and the amplitude of the waves is added and will give you the more intensity. So let's have a difference as shown over here. So this is another wave. Okay, this is traveling and traveling up to here, and this is the second wave, okay, and this is second wave is traveling over here. So क्या यहाँ पे आपके पास क्या, this wave is cancel out the behavior of another wave, so they are out of phase, the both waves are the out of phase. So you will see there is after this there is no sum of the waves, and you will see nothing with the when these two waves which are out of phase meet together and their amplitude is nothing, zero amplitude. That means they are going to cancel out the effect of one another. And here you can find if these are the in phase, you will find the more amplitude or the intensity of the wave, because this is the due to the constructive. First one is A and B is the constructive interference, and the second one is the destructive interference. So now come to the electron diffraction. Here you can see more clearly actually what is happening and what we are going to do with these constructive or the destructive interference. So let's see here, these are the atoms, any materials, and these are the, let's suppose, the first layer of atom, second layer of the atoms, and these dots are the electrons. So if you are going to bombard or to interact these electrons with the outer source electrons, that means you are following the electrons on the any material, then what is happening? These are going to scatter, because these are the particles. Particle when hit together, they of course they should be scattered depending on what is the intensity, what is the speed, what is the kinetic energy of the electrons. Okay. So what is happening over here after interacting? After these are the beam of electron, after interacting with this electron, and these are going to be reflected in this direction. Okay? So ये आपके पास, and this is showing, this is having the particle like properties, because electrons are the particle hitting the particle, that means they are going to be diffracted. No, diffracted means they are going to scatter or changing their incident angle as compared to the outcoming angle. And here you can find actually what I am going to show over here. So these, for simplicity, when the electrons are traveling, that means there is also a wave. Wave is there, always it must be a wave. Here due to the simplicity, it is shown by a solid line. But these, if the electrons traveling, and it must is having the wave, and it is also diffracting after this point, and then it must also have a wave, this because it is having the wave-like properties. And this portion in blue in color I have shown over here. ठीक है, जो अभी आपको बताया. अब इसमें देखें, this is the wave, इसको गौर से देखें. Starting here, ending over here, one wave, and this is the second wave. Okay. Similarly, third wave, fourth, and this will be going proceeding until it is stopped by another material. Okay. So what is the difference between the first, this wave, and this wave? Again, this is going to be travel. This is the one wave, and again two wave, and this is also traveling. So what is the difference between first, second, and the third? हाँ जी, और बताएं. What is the similarity between these two? These are all are the same, because completing the wave length of one wavelength and then proceeding with the same lambda. Okay. तो ये अब आपको यहाँ पे बताना ये चाह रहे हैं कि ये now look I have over here, ये first इलेक्ट्रॉन के ऊपर ये हिट किया, ये सेकंड ये इलेक्ट्रॉन था इसने हिट किया. How much more distant it has traveled from this to this? This is the more distance traveled by the electron as compared to the electron which is hit at this point. ऐसे ही है. एंड थर्ड पे देखें, ये पॉइंट जो यहाँ पे हिट किया करने के बाद जो है, अगर हम इसको लेते हैं, हाउ मच मोर डिस्टेंस इट हैज ट्रेवल्ड फ्रॉम हियर टू हियर. ठीक है. और सेकंड ने जो है वो उससे कम डिस्टेंस दिया, एंड दिस इज स्टार्टिंग फ्रॉम दिस पॉइंट. सो आई एम गोइंग टू कंपेयर ऑल दीज two waves with the first one waves. That means how much extra distance is traveled by the electron at this point, at point E, and at this point. Okay? Now I'm going to and this is the extra distance, means I am talking with the length of the wave, because this is important. So here distance is the length of the wave. And if you have a look over here, and this is the same line line which is drawn over here. सही है, सेम लाइन जो है यहाँ पे भी है. अब देखें यहाँ इस लाइन के बाद जो है सारी एक ही जैसे बिहेवियर आपके पास चल रहा है. ऐसा ही starting from here, this is also starting from here, and this wavelength is also starting here. And what is the wavelength before this line? How much extra wavelength or how much extra waves it has traveled at this point, E point? How many waves are there? 1 lambda. Okay, and why 1 lambda? Because here this is the half, and this is another half. This is a complete wave. One wave is traveled more as compared to the which is the beam of electron falling at point B. I say it. And what is the difference with the first? How many wavelength? 2 wave, 2 lambda. ठीक है, ऐसे ही one is here, one, and second is over here. And this is called the constructive interference. If this is not happening, then there is no constructive interference. क्या उसमें होगा? लैम्डा n लैम्डा जो है वो प्रोसीड करेगा. n लैम्डा होगा, 2 लैम्डा होगा, 3 लैम्डा होगा, and these are the perpendicular to each other. सही है, x और y ऐसे ही फेज आपके पास ये फेज. This is x, this is y, this is in the same phase, and z is over here. ठीक है, these and these are the perpendicular to each other. ये x आपके पास है और y उसके क्या perpendicular with the right angle with the 90 angle. So x and y are on phase, and when they meet with the same lambda, then there is the constructive interference, and the intensity of the individual wave is sum of the intensity. The intensity of the wave will be the sum of the intensity of the individual wave. ठीक है, तो ये आप कब आएगा? जब आपके पास जाए ये जो आपके पास शो मैंने किया है, सही है, इस फिगर के अंदर अगर ये बिहेवियर आ रहा है, then it will be the constructive interference, and that would be called because the electrons are diffracted, and this is called the electron diffraction, and this is similar to the X-ray diffraction. So we will study, you will study in the higher courses how can we actually the purpose of this one. This is another equation, but it is not the part of your syllabus over here. So important is this is the n lambda, n will be 1, 2, 3, 4, and when 1 lambda, 2 lambda, or the 3 lambda. And here, what would be the lambda over here at this point? 3 lambda. सही है, 1, 2, and 3. Similarly, आपके पास ऐसे जो है वो चलेगा. And this is all about the diffraction. इसको मैं